Obtain the state space representation of armature controlled DC motor and field controlled DC motor. If it is the field controlled DC motor, this is constant. This is constant. That's why there is no equation for this L and R. IA is constant. Armature. The field produced by this is by EF of T. EF of T. Field produced by this is EF of T. So it has L, F and RF. So the equations are, there is the electrical equation is E field of T equal to L T IF. Current through this is IF. Field current. It is controlled by field. DIF by dt plus RIF. RIF. There is no back EMF here. First equation. Second equation is J d square theta by dt square plus B d theta by dt equal to Tm, as we have seen in the previous. The third equation is Tm equal to Kt IF, not Ia. That is third equation. Only three equations. Now, let us assume that theta equal to x1 equal to, implies that x1 dot equal to theta dot equal to x2. This is the first state equation. We can find for, now replace this by, and we are assuming that theta equal to x1, theta dot equal to x2, two state variable. Third state variable is IF equal to x3. IF equal to x3. That is the third state variable. So now substitute EF of T equal to L Tx3 by dt plus Bx3 Rx3. That is one equation. Therefore, it can be written as EF of T equal to L x3 dot plus Rx3 implies x3 dot equal to EF of T divided by L minus R by L x3. This is the first equation. X3 dot we got. Similarly, we can find x2 dot from the second equation. This is first equation implies this. Second equation implies J x2 dot plus Bx2 equal to Tm. Tm equal to Kt. IF is x3. That's all. Therefore, x2 dot equal to, this is second and third. Both the equation together gives this. X2 dot equal to Kt by Jx3 minus B by Jx2. This is second equation. Already we got one equation. This is the third equation. X1 dot equal to x2. Now we have to put all together. In state space means x1 dot, x2 dot, x3 dot equal to x1, x2, x3 plus E field of t. So x1 equal to x2, therefore 0, 1, 0, only x2, x1 dot equal to x2. x2 dot equal to what we got? Only it is function of x3 and x2, therefore 0 minus b by j kt by j. x3 dot equal to, here we got x3 dot equal to, that is function of x3 alone, therefore 0, 0 minus r by l x3. Here EF of t is in the final equation only 1 by L 0 0. That's all. In no other equation EF of t. This is mathematical model of field controlled DC motor. Field controlled DC motor. Mathematical model of field controlled DC motor.